Today I'm very happy if you can participate in this very actively, and this class also can be a turning point in the lives of many of the students, because it is a very important class in my opinion. Sweet 16. Today is sweet 16 also. To eat sweet, eating sweet is poison, but leaving sweat is amrit. Yes or no? Sweet and sweat, lot of difference is there. Sweat means, when do you say sweat? You are working hard. You are learning. That is known as sweating. You are putting your best efforts. That is called sweat. The opposite is sweet. Okay. A few pictures to just brush our skills. The last chapter of this subject is distribution of water. We already had the introductory part of this with the very second chapter, where we have studied the water supply system and a few points we have studied. And today in this particular chapter we will be studying the design aspects of various distribution system, how to maintain a water supply, what are the various valves and appurtenances involved in that, and in a pipe network, in a zigzag fashion, several pipes will be going. If a main pipe goes, to that laterals are connected, to that arterials are connected, to that sublaterals are connected. Like that, ultimately when certain amount of water enters in a particular section of pipeline, how much flow is there? How many people it can cater to the needs of how many people? If you want to know it, then this sort of method is known. It is known as Hardy cross method. All these things you will be studying in this final chapter. But before going to the final chapter, let us brush our skills related to, because this is 90% of fluid mechanics only. So you should be very thorough in fluid mechanics. That is why whatever you studied in first year, physics, chemistry, several aspects, even mathematics, some important points, not all, they will be applied in the subjects which you study in second year. In fluid mechanics, if you do not have the basic fundamentals, you need not know everything, but basic fundamentals if you do not have, next step of hydraulics or hydraulic machines or even water supply engineering, everything is like Greek and Latin. You cannot understand in it. Long ago, I belonged to a place called Bhimavaram. From Bhimavaram, I came to Kakinada to listen to Mahakavi Sri Sri. He talked only for 2 minutes, and while leaving, he was asked, "What is knowledge?" And Mahakavi Sri Sri replied, "Whatever you remember 1 year after the examination is over, that is knowledge." So you have studied in second year, you have studied fluid mechanics. So whatever you remember, important points of fluid mechanics, you may be remembering 2 points, 10 points, hardly something. Whatever you remember now, that only is knowledge. So similarly, today you will have you are studying this subject. After exactly 1 year, you will have the gate examination. Whatever it comes to your mind that particular time after my today's class, that is knowledge. And this knowledge one gets only when he shares his knowledge, whatever he has learned in the class. If he shares it with his friends, if he discusses it with his friends, then only his knowledge multiplies and it comes permanently in memory. It is permanently stored throughout life. Once or twice you have to explain to your friend, that's all. Then throughout life you will remember it. Yesterday, when the university organized a function called Saudha, a festival, one student, he came and he was saying that your classes you tell repeatedly about gate examination, how simple it is, but I always had the opinion that it is very tough, it is not my piece of bread. So I did not show interest. But I was listening to you and I prepared only a few days before the exam very seriously. But I got 8 marks only because of your class. So even this subject of Mooc also, if you are thorough, this 1.5 hours if you pay your attention sincerely, then that is more than sufficient. 8 marks, you know, it is very big thing. Very, very big. In addition to that, this type of learning, it helps you in solving other problems also. Okay, let us see some of the important gate problems, but before that, let us brush our skills related to this for some time. Next, please. This also is a pipe flow only. Today we have only 16 slides. And what is this diagram? Just observe. It is a very good topic for a question to be asked in the GATE examination. When I say GATE, it is all government jobs through GATE only. Several foreign universities, admission in MS, it is through GATE only. And whatever you study for GATE examination, even if you are not selected, knowledge is never wasted. Even for jobs in APPSC or Group 1 examination, anywhere you go, this sort of thinking, this sort of preparation will always help you. Okay. So what are the questions that are possible from this? This diagram is called Moody's diagram. Moody's diagram is drawn dash versus dash. It is drawn friction factor versus Reynolds number. Whatever is drawn on the y-axis, that only you should say first. If you don't tell it, it is wrong. In the GATE examination, he may give B as Reynolds number versus friction factor. He will give Reynolds number versus relative roughness. All of the answers are wrong. If he says that it is drawn relative roughness versus Reynolds number, that also is correct. But this sort of keen observation only will help you. So what is the correct answer? Moody's diagram is drawn friction factor versus Reynolds number, or relative roughness versus Reynolds number. What does it mean? What does it give? What is the main analysis part of this? This is a logarithmic type of thing. So this is 1000, 2000, 100, 1000, 10,000, 1 lakh, like that it is going up. Logarithm of 10 square is 2. Logarithm of 10 cube is 3. Logarithm of 10 to the power of 4 is 4. That is why this is linearly placed, but it is logarithmic expression. So this value, this is Reynolds number, x-axis. This represents, it is, Reynolds number is 2000 here, 2000. This represents Reynolds number of 4000. This represents Reynolds number of 10 to the power of, this is 10 cube. That is, this is 10 to the power of, this is 10 cube. This is 10 to the power of 4, that is 10,000. This is 10 lakhs. This is 1 lakh, like that. Now, we know that if Reynolds number is less than 2000, flow is laminar. If Reynolds number is more than 4000, it is turbulent. If it is in the range of 2000 to 4000, it is transitional. Trans means change. In English, trans word means change. Transformer means it changes the form of electricity. From electrical energy to magnetic energy, or high voltage to low voltage, it changes. That is why it is transformer. Okay. So, you are seeing that this is laminar flow. That means this is up to a flow of around 3000, 2000, the flow is laminar. Why it is straight line? Why it is straight line? Suppose the friction curve is drawn versus friction factor versus Reynolds number, it will not be straight, because in this zone, F is equal to 64 by RE. 64 divided by RE. So it is something like y is equal to 1 by x. How the curve xy is equal to constant appears? It will not be a straight line. But why it is a straight line? Because the x-axis is not linear. It is logarithmic. So when it is 1000, I have marked this is 1000, this is 100, this is 1000, this is 10,000, this is 1 lakh, this is 10 lakhs, and this is 100 lakhs. So as a result, when you take the logarithm of it, you are getting in a linear way. That is why you have got this as a linear one. Here is like this. But let us say this is one pipeline. This is for a pipeline. How Reynolds number is how friction factor is very. It is straight line. It is not changing. That means all this zone is turbulent flow. That means in a turbulent flow, friction factor does not vary with the Reynolds number. It varies only with the type of the pipeline. These are different pipelines. This is riveted steel. This is concrete. This is wood. This is galvanized iron pipe. This is corrugated pipe. This is a cement concrete pipe. So these are all varying like that only. So this is an important point is friction factor does not vary in case of turbulent flow. Friction factor does not vary with Reynolds number. It varies only with the type of the material. When it is laminar flow, friction factor is inversely proportional to Reynolds number. F is equal to 64 by Re. So as Reynolds number increases, friction factor decreases. Next please. We have seen it already. In case of all pipes, whenever we say diameter, diameter means inner diameter of the pipe. Whereas in case of plastic pipes, it is generally denoted as OD. But when we design pipe, that is always inner only. When we say diameter, it is inner diameter only. That means, suppose you have designed the pipe diameter as 50 mm. When you go to market and ask for a pipe, if you ask for a 50 mm diameter pipe, he will not give that. He will give a pipe of outer diameter 50 mm only. So you have to make him clear that the inner diameter should be 50 mm. That means he will give the corresponding outer diameter corresponds to 63 OD. So when you design, you should know that when you are saying that the pipe, when you are designing, you have to design the material also you have to tell. So when you are suggesting a plastic pipe, you should say that the OD, that is outer diameter, should be 63 mm. This is a very small point. Maybe not that important, but you should know these things. Next please. Next. We have already seen this, that steel pipes, they can withstand any amount of external pressure of 30 kg per centimeter square, 50, 100, 250 kg per centimeter square also steel pipe can withstand. Internal pressure. But when it comes to external loading, even if vacuum is there inside, that means the net pressure external loading, net external loading is 1 kg per centimeter square, it collapses like a piece of plastic. Next please. Once again we have seen that whenever diameter is more than 2 meter, steel pipes are preferred to cast iron pipes. Similarly, if internal pressure is very high, let us say more than 20 kg per centimeter square, then that is 200 meter head, then also steel pipes are preferred. In case of penstocks, which used in thermal power, in hydropower plants, where the head is, let us say, 500 meter, that means pressure is 50 kg per centimeter square. Steel pipes only are used. And in case of RO units, the pressure is more than about 15 kg per centimeter square, like pressure is maintained. So there also steel piping only is done. Next please. Okay. These are all you should know that Sri Salem power plant, repeatedly I am telling because pictures are very catchy, and the moment you see a figure throughout life you will remember these key points. And write one more point, in Sri Salem power plant the turbine used is called turbine pump. What is meant by turbine pump? Please do not think that I am praising myself. It is not praising myself. I want you to know the importance of such type of small points. One of the persons working in Sri Salem power plant, he is a student of, he is our student here. He was telling that in the class, whatever you explained about this particular point, it helped me when I appeared for an interview. They asked, what is a turbine pump? What is the beauty of Sri Salem power plant? I told about this particular point. See, turbine and pump, both are, if you see the components of it, it is more or less the same. For example, the rotating element in case of pump is called an impeller. rotating element in case of a turbine is called runner. Yes or no? The rotating element is known as runner in case of turbines. In case of pumps it is known as impeller. But structure-wise both are same, more or less. Both are vanes only of particular size and shape. And both are surrounded by something like a spherical thing which is called casing. In turbine also that casing is there, in case of pump also the casing is there. Internally when you see it actually, turbine and pump, there is no great difference. Both are more or less identical only. What is the function of a turbine? Water is stored to a great height. It has lot of potential energy. Water has lot of energy in it. That energy or potential energy is converted into electricity by the turbine. Or first mechanical energy and then electrical energy by the turbine. Whereas what is a pump? It is converting the electrical energy. When you switch on, it is converting the electrical energy to the hydraulic energy. So pump converts electrical energy to hydraulic energy, whereas a turbine converts hydraulic energy to electrical energy. So in case of Srisailam power plant, what happens is, in 90% of the cases, the turbine works as a turbine only. In case sufficient water is not available, then the same turbine, it acts as a pump. So in the tail race, whatever water is available in the down, that water it pumps, lifts, and that water it again uses for generating power. The rare case, it has its own advantages. So the Srisailam power plant turbine, it is a turbine only. But once in a blue moon, once in a while, once in a blue moon means once in a while, when situation demands or there is an acute shortage of power, something like that, there is no water also available. In such type of cases, there is no water also available. Then, but some water is there available in the tail race. So that water is lifted by the same turbine because it used as a pump. So what happens? It sucks water from that, it lifts water to a height. So it acts like a pump. And after that again, when sufficient amount of water is there, this thing it acts as a turbine. Water from the great height it comes, it rotates the runner and the electrical energy is generated and that water reaches the tail. So this is called reversible turbine or turbine pump. So Srisailam power plant has this unique feature. You need not completely understand this. You need not completely understand. People don't expect that you are very thorough in everything. But it shows that the moment you start explaining to some extent, it shows that you have interest. And you have given some attention when the teacher was telling. That's all. Once you have that quality, you are very easily trained. That is why this quality is very important. You need not have to explain very in depth for that. But you should know basically to some extent. Okay. Next please. So this is the third largest hydropower plant in India. 6.1 meter is the diameter of the penstock. Penstocks are always made of steel pipes only. Cast iron is not used, RCC is not used. There is no external loading in case of penstocks because deep in Srisailam power plant is completely constructed inside a huge hill. A truck cannot go on that steel pipe. Next please. Okay. This is the question which has actually many students in 2016, recently, February, many students they said that the almost like turning point, they jumped with joy when they saw this question, that too for 2 marks. And I have solved this problem with more or less the same numericals also. I'm sure many people where I have trained outside must be thinking that maybe this particular air pollution, because a book also is written by me, prescribed book is mine, I only have given the question. Like that they may think also. But I have not given any question paper. I have not set even a single question. The question is very simple. Once again I am telling you, if you show interest, my dear friends, apply your mind. When you are in the class, be professional. Whatever you are doing, be involved in that only. You need not know the subject. Engineering is problem solving skill. Problem means you do not know the answer. If you know the answer, what is it you will do there? You do not know the answer, you put your efforts to solve the problem. Use just common sense, just common sense. In English language there is a word called simpleton. Simpleton means a person who does not have common sense, comma, stupidity. Don't think that if you do not have common sense, it is a good quality. It is not innocence. It is stupidity. And it does not, anybody can answer. Every student of the entire state of Andhra Pradesh or entire country, anybody can answer. Only thing is you have to apply a bit of your mind. Common sense you have to apply. The question is, number of 6 meter long, 0.3 meter dia bags required to treat 10 nm cube per second. N stands for normal meter cube. You need not get confused by that. N is a general, it is a style of telling when it comes to air. Whenever gas flow or air flow is described, it is expressed as nm cube. N means normal temperature pressure conditions. Because water, its volume does not change with temperature. Whether temperature is 20 degrees or 40 degrees, volume of water does not change. But when it comes to gas, as temperature changes, volume increases. As temperature increases, volume of the gas increases. Yes or no? Gas or air, if the temperature increases, what happens? Volume increases rapidly. And temperature changes or not, even outside. Morning it was 25 degrees centigrade. Now it is 32 degrees centigrade. Afternoon it may be 37 degrees centigrade. Night again it will be around 22 degrees centigrade. It changes. For each 1 degree centigrade change in temperature, the volume of the air changes rapidly. So an equivalent term must be maintained always. So at whatever you are saying, its equivalent at normal temperature pressure conditions is denoted as N. So don't get confused. It is in simple terms meter cube only. Whatever you are thinking, which meter cube, the same meter cube. Some people they express it as SM cube also sometimes. Then you should understand that it is standard temperature pressure, it is normal, or both are same. NTP conditions means normal temperature pressure conditions. What is meant by STP conditions? Standard temperature pressure condition. There is no great difference. Okay. So the flow is given as 10 meter cube per second. From the an industry is releasing dust laden gases at a flow of 10 meter cube per second. They want to treat it using a filter bags. Each bag is of size 6 meter long and 0.3 meter dia. The design filter ratio is 2 meter cube per minute per meter square. If you are correct, it is 2 marks. If you are wrong, -1 mark. Some questions there are no negative marks. For example, now in the gate examination, fill up the blanks also are there. Fill up the blanks. You have to put some value. In such type of things, there will not be anything like what you call negative marks. For example, this may not have a negative mark. Anybody has done it? You need not do anything. Just common sense and units. Units are very, very essential. Very essential. I am telling you, after your final year, when you go to any standard coaching center, and every day morning 6 to evening 7 or 8 o'clock classes will be held. You will be attending sincerely. but you will not be qualified for gate examination. Unless and until you are proactive. Proactive means you are participating in the solving. Don't bother about result. Just observe units. Meter cube per minute per meter square means, what is the unit? Meter cube per minute per meter square or meter cube per meter square per minute, both are same. So it is meter per minute. That means meter per second you should convert. And this is meter cube per second. You divide, you will get meter square. What is the area of each bag? Whose diameter is 0.3 meter and whose length is 6 meter. What is the formula for that? Pi d square by 4. These are all the small mistakes you should not do. Telling a wrong answer will become a habit after some time. Somebody is telling pi d square by L. Common sense should tell you that pi d square is meter square. L is meter. You are getting volume meter. We are interested in the area. Area of the filter through which gas is flowing. Pi d into L. If you do one mistake, you are gone. Entire gate examination is gone. Don't be in a hurry. Be calm and cool because you are the best. Next please. So this is typically a bag filter. All of you pay your attention please. How it is treated is, the 10 meter cube per second of gas, all of you please listen to me, please look at the picture. Try to travel along with the teacher, it helps you. I will give you a lot of time. The 10 meter cube per second of gas, it enters from this, through this pipeline, like this. And all these bags, these are all the bags, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bags. These are all connected to this like this. These are all connected to this. So what happens is, you are seeing some small laterals or pipes here. This gas enters, this is bag filter. Inside this, you are seeing that it is not actually metal. It is a cloth only. But sometimes what they do is, to support it like this, internally some metallic strings may be kept. But basically it is just like a gunny bag, Gon Sanchi, of a special quality, depending on the temperature of the gas. So this gas, it enters like this, through this. And it comes out of this bag filter. The entire, this area, this perimeter is pi into D. D is 0.3 meter here. This is about 1 foot diameter. So pi into D is into L. This is 6 meter. This bag length is 6 meter. So what is the area through which the gas passes through that? Is pi into D into L. That is the area available for each bag. That's all. Now the question is, so like that this gas enters through all these bags and it escapes, comes out. And here outside there is another chamber kept here like this, and through this gas flows out through this. There will be a pump, exhaust pump, which will suck all this, and this gas will escape into the chimney. You need not understand all these things to solve the problem. But you should guess that there is something like a bag like this. Just take this bag, particular bag. This particular bag you take. How gas is entering? Like this it is entering. It is through this bag, it is going out. So the top portion of the bag should be closed, obviously. Otherwise what happens? If this is not closed, the entire gas will go escape by origin without any resistance. Through the pores in the fabric, it is filtered. So how it is cleaned? Just like backwashing in the reverse direction. When after some time what happens? Each bag is coated with a lot of dust like this. This is called dust resistivity. So it cannot treat any gas further. So at that stage, the whole system is shaken thoroughly, And air, pure air from compressed air, this is C means compressed air. This compressed air is sent in the reverse direction, just like backwashing in case of a rapid sand filter. So this bag is completely cleaned. All the dust, it falls here. This is called dust collector. So what is the area of this? Pi into D into L. How many bags are placed? These are 10 bags. Another 10 bags are placed here. Another 10 bags are placed here. So all these are housed inside a chamber. That is called bag house. Bag house is nothing but it is a system where number of bags are housed. Each bag is of diameter about 0.3 meter and length about 6 meter. Next please. So this is the solution I have given and you must have done it. And if you are nearing this, then you are fine. How many of you have done it? Oh, super, super, super. Great, great. This is great for you. The total area required is 10 meter cube per second divided by 2 meter per minute, because this is 2 meter per minute. So 10 meter cube per second divided by 2 by 60 meter per second. You will get 600 by 2, 60 into 10, 600 by 2, 300 meter square. Area of each bag filter is pi into D into L, pi into 0.3 meter into 6. It is equal to 5.66 meter square. So how many total number of bag filters are required? 300 meter square divided by 5.66 meter square is equal to 53. That's all. And you should know that this is there in syllabus. In the gate examination, in the syllabus, this is there. And you need not know it. Environment studies you have studied. You have environmental engineering. Next semester you have another subject of environmental engineering. I am not going to leave you so soon. I am going to walk with you the last mile. So, in that it will be taught. But all this is not required. If you apply your mind, just observe units, you can solve it. And to solve something, you need not know it. You have to apply your mind and then be calm and cool, put pen on paper and put your best efforts, that's all. You need not, answer is not important. Your efforts only. Is it clear? Very simple. What happens, suppose a similar question is asked, say more or less same question is asked tomorrow in the gate examination. Then do you know how bad you would be feeling? That is very, very simple. Everybody has done it. Just because of 1 or 2 marks, your entire career, next 70 years depends on that. Yes, please. Now, all of you, please be serious in the sense, be in a very relaxed and free mind. Vivekananda said freedom is the first condition of success. Listen this with a very free and open mind. I will give 15 questions now and I will give you 15 minutes of time. Let us see how many of you will answer it. I am sure if 2 of you, if you get 2 marks out of these 15, 2 marks, take it for granted, you will be definitely selected for gate examination. But each question carries 1 mark and negative mark is -1. That means if you are wrong, you will get -1 mark. So, you solve it only if you are damn sure that it is correct. For fun, don't put the answer. Put your best efforts in. I will give a lot of time. Today whole class is for this only. And you should appreciate the advantage of this is, all the 15 questions are related to environmental engineering 1, that is this particular subject. All the 15 questions are related to fluid mechanics and hydraulic also. So that is doubly advantageous, that 2 birds, 1 shot, 2 birds. Okay. You have to maybe note down the question briefly so that you can understand. I will give you 3 minutes time for each slide so that you can note down the question or try or something like that. I will go a bit fast and don't worry, I will again come back to the same slide once again. So if you have not noted the completely well also, don't worry. Go to the next slide. Always live in the present. Suppose I am in a hurry and immediately switch it on to the next slide. Don't think much about it. Be in the present. That means observe the second slide. So the first question is, the theoretical range of velocity in an economical pumping main is dash meter per second. Second question is, Reynolds number is proportional to A, D, D1 by D, C, D square, D, D to the power of minus 5. Slope of HGL in a pipe with RE is equal to 40,000 is proportional to A, D square, 1 by D, D to the power of minus 4, to the power of minus 4. Fourth question, slope of HGL in a pipe with RE is equal to 1600 varies with. And the fifth question is, which is suitable if pipe has a diameter of 3 meter and internal pressure is 30 kg force per centimeter square? Some of the questions I have covered just now, 10 minutes before. Whatever you remember 1 year after the examination is over, that is knowledge, Sri said. But unfortunately, we do not remember whatever you have studied now. After 10 minutes you are forgetting. Leave about 1 year. Next please. Always try to note down in a telegraphic language, in a shortcut language, so that you should spend more time for answering it. Next question. This time is for answering also. Friction factor of a pipe varies with dash. The flow in a municipal water supply is usually dash. You need not write actually the answers at all. ABCDs are not important. You can directly write your answer. Don't write ABCDs like a child. What is it you will do with ABCDs? You write your answer. (16.8) Critical velocity in a CI pipe of diameter 1 meter with a liquid of kinematic viscosity so much is equal to dash meter per second. Next, equivalent pipes have the same dash and dash. 16.10 20 centimeter CI pipe has a length of 1000 meters. The length of its equivalent pipe of diameter 40 centimeters is equal to dash. Next, hydraulic radius of a canal of square cross section of side A is equal to dash. This is a very, very beautiful question. If you ask me, it is my most favorite question. Just like that back filter has fetched you 2 marks, some 4-5 years before, students they came and said that this question they gave exactly as it is. It's not an exaggeration. Some students they said that when you gave us this question, we thought you are a sadist. It is really sadism, that question, first question. But once you appreciate and understand the answer of it, you will get so much of thrill. No other can give so much of kick. When you solve a problem, somebody has created a problem for you. He has created a problem. I have created problems to you. I have created 15 problems for you. You will get happiness only when you solve me. By scolding me, you will not get anything. Moody's diagram is drawn dash versus dash. Hydraulic radius of a pipe of diameter D running half full is dash. If head loss in a turbulent flow is expressed as H is equal to K Q to the power of M D to the power of N, then values of M and R, same question is repeated 16.15. Please go back to, okay. Done, everybody? I will go back to slide 1, first 5 questions. Sorry, previous slides. 10. Yeah. 1 more minute of time I am giving you for slide 1, first 5 questions. I will give 1 minute for each slide now again, and then I will answer. I will tell the answers. So most of the questions, if you know, you know. If you do not know, you cannot do anything. Some questions are like that, but some questions are not like that. If you think, you will get the answer. Put pen on paper and start doing something. In fluid mechanics, any problem can be solved by writing two equations. The first one is called continuity equation. Q is equal to A1 V1 is equal to A2 V2. A is area, V is velocity. So whether it is useful or not, in fluid mechanics or in such type of problem, put the formula first. Q is equal to A1 V1 is equal to A2 V2. Put it first. You will get a lot of confidence, energy. That will drive you. An eagle, when it flies at 5 kilometer height, for a long time it has no food, it doesn't eat food. Do you know how it gets energy? The wind energy only it converts into its own energy. So as it works hard, it gets more energy to work more. So when you write continuity equation, you will get a lot of energy. Your thinking ability improves. Next you write Bernoulli's theorem. P1 by W plus V1 square by 2G plus Z1 is equal to P2 by W plus V2 square by 2G plus Z2 plus HF. In this particular case, it is not applicable. For all these 15 problems, this will not come. But in any problem, whether it is required or not, first write down. For the entire gate examination, 3 hours, you have to write once, somewhere or other. Generally, that is one style of using all problems related to fluid mechanics you will solve at a particular time. Next please. And always use common sense. Whenever you get a diameter as a 25 meter diameter, 25 meter diameter, is it possible? You should know that it is 2.5 meter or 0.25 meter. So you have to cross check. Next please. This is the previous slide. Okay. I'm giving 1 minute time. Do it with bit hurry. I'm sure every one of you are participating. Now, this sort of programs, university, it starts with a lot of high ideals, with a lot of hopes that the important lessons should reach even a student studying in the remote college of the state also. That is the only idea our Vice Chancellor, Professor V.S.S. Kumar, who is also from the same branch of civil engineering, he has initiated this. So the student should get benefited. And all this property, you are the owner of this property. Every student of JNDU who is listening, you are the owner of this property. This property is yours. This knowledge is yours. But only when you use it, it is yours. If you don't use it, and throughout life, any competitive exam you attend, I can challenge that you will get at least 2 or 3 questions related from these 15 questions. Not directly, but their impact will be there. Their presence you will feel. Rome is not built in a home is a very famous statement by a civil engineer. You cannot build an empire of your own in a single day, but every day you have to put some efforts. Okay, next please. I am giving half a minute time for this also. Do in a systematic way, write in a systematic way, always write units, 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 units. How important a dress is to us. Cloth is, how important cloth is to us. The same way units are to numericals. Every numerical, the corresponding unit must be there. The moment you write units, you will not do mistakes. Otherwise you will say things like this only. When asking for area, you will immediately say pi d square into pi d square by 4 into L, you will say. Pi d square by 4 into L is unit, meter cube is answer. It is wrong. Your mind will tell. Doing it is not a mistake. But the moment you write units, you will not do that. Because you will get the answer in meter cube. You are writing area. Pi d square by 4 into L means you will write it in meter cube. So immediately you will correct yourself. Always be open for correction. Be ready to correct yourself. Okay, thank you. Let us go to the solutions now. Go to 12, 13, 14. Yeah. These are the solutions. What is the theoretical range of velocity in an economical pumping main? It is, what is the formula connected to that? You have done it already, that economical diameter D is equal to 0.97 root Q to 1.22 root Q. You take any one particular thing. Let us say you take it as D is equal to root Q, or 0.97 means almost 1 only, into root Q. You square both sides. You will get D square is equal to 0.97 square into Q. What is Q? Use continuity equation. If you do not know, use continuity equation. That is ultimate weapon. Area and velocity. What is area? Pi d square by 4 into velocity. Velocity is the answer, you have to get it. So you will get the velocity as 1.33 meter per second. If you take the value as d is equal to 1.22 into root q, if you do it again, you will get velocity as 0.85 meter per second. So the answer is 0.85 meter per second to 1.33 meter per second. For normal pipes, the main parameter for design of pipes is assume velocity as 1 meter per second. 1. In fluid mechanics, most of the problems, if you do not know the answer, raise your finger like this and say 1. You are 99% you are correct. Specific gravity of water is 1. Specific weight of water is 1 gram per cc. Kinematic viscosity of water is how much? 1 centistroke. What is dynamic viscosity of water? 1. Some poise, centipoise, something. What is the temperature at which ice is melted? Water it becomes solid to ice. What is the temperature? Roughly, just to remember it, around 1 degree centigrade. What is the velocity maintained in pipelines? 1. Okay. So this first question. Second question. Reynolds number is proportional to 99.99% of the engineering students, they know that Reynolds number is equal to Vd by nu. So Vd by nu. Nu is kinematic viscosity. So immediately based on this, they will say that Reynolds number is proportional to velocity, Reynolds number is proportional to diameter, Reynolds number is proportional to viscosity of the fluid, inversely proportional to viscosity. One, that is Reynolds number is proportional to 1 by nu. But that is wrong. In fluid mechanics, velocity is not the most important and critical parameter. We should always talk in terms of discharge only. Discharge only is the key parameter. That is the governing factor. In terms of discharge only. This man Reynolds has conducted an experiment and gave the value like this. We should not use it directly. Vidya Vanayaha. Vanayam means application of Vidya. Whatever Reynolds has to, you have to apply in it, you have to change the form of it and apply it. So you should convert it into, in terms of discharge, you should convert. Another pen, red. Okay. So this becomes 4 into Q into D by pi nu D square, because velocity is equal to discharge by area, pi D square by Q by pi D square by 4. So you will get like this. So Reynolds number is proportional to Q to the power of 1 and 1 by D. So the answer is 1 by D. 1 by D is the answer. So don't give the answer just by looking at this. Anybody will do that. In gate examination you have to think, maybe a bit you have to think further, that's all. Once you know it, you can solve so many other problems. The third question, slope of HGL in a pipeline with RE is equal to 40,000 is proportional to dash, D to the power of minus 5. How many of you are correct? Good. What is the reason here? HF is equal to FLV square by 2GD is Darcy-Weisbach equation. We all know that. So again V you have to convert it to V is equal to Q by pi D square by 4. So V square is square of that. You will get 8 FLQ square by pi square G D to the power of 5. This is a very important formula. Every one of you must remember. Must. It is a 100% beautiful formula, because this is 100 actually. Pi square is a 10. G is 10. So pi square into G is 100. So this figure is 100. It should continuously tell you that this is 100% correct formula. So it shows that head loss is proportional to Q square, head loss is proportional to L, head loss is proportional to 1 by D to the power of 5. So the answer is 1 by D to the power of 5 means D to the power of minus 5. And how you should apply this formula? Reynolds number is 40,000. Reynolds number is 40,000 means flow is turbulent. If it is more than 4,000, flow is turbulent. In case of turbulent flow, you cannot use Hazen-Poiseuille formula, which is used only for laminar flow. Only two formula you have to remember. One is Hazen-Poiseuille formula. The second one is Darcy-Weisbach equation. 90% it is Darcy-Weisbach only is applicable. That's all. Next. What is slope of HGL means? HF by L is called slope of hydraulic gradient line. Slope of hydraulic gradient line S is equal to HF by L. HF is head loss due to friction. L is length of the pipeline. So HF by L is called slope of HGL. So HF by L is proportional to A is equal to 8FQ square by pi square G D to the power of 5. Now, same question. Slope of HGL in a pipe with RE is equal to 1600 varies with dash. You should understand that RE is 1600 means flow is laminar. Flow is laminar means Hazen-Poiseuille formula is to be used. What is that formula? HF is equal to 32 mu V L by W D square. This comes to what is V discharge by area? Q by pi D square by 4. Have you got the same value? 128 mu Q L by pi W D to the power of 4. So what is the answer? D to the power of minus 4. But the same question may not be given. He may say that it is in a different form also. You have to observe that in case of turbulent flow, it is proportional to square of the discharge, Q square. Whereas in case of laminar flow, it is proportional to Q to the power of 1. It varies linearly here. Which pipe is suitable if pipe has a diameter of 3 meter and internal pressure is 30 kg force per centimeter square? Okay. Steel pipe. Diameter is more than 2 meter, it is steel pipe. But why he has given it as 3 meter? It is a gate examination, they do not want to take a chance. Anything more than 2.1 meter also, it is steel only used generally. But he does not take chance. That is why he has made it 3 meter. And any pressure more than 20 kg per centimeter square, cast iron is not used. RCC, they all become useless. HDPE, they are not used for high pressures. Only cast iron used. Cast iron also for a head of 200 meter. That is 20 kg per centimeter square. So that is why he has given it as 30 kg face per centimeter square. 1 kg force per centimeter square is also called 1 bar. So in next examination he may give it as 30 bar. You should not fumble. Next please. I will not ask at the end of the paper, I will not ask you for how many questions you are correct. You are your own police. Your conscience is your own police. What is the meaning of the term conscience? Please write the spelling first and then see the meaning. First write the spelling. In English language always con, con, that word when it is used. Concurrent, congenial, confidential. Con word has a specific meaning. You should think always like this. If you think like that, your vocabulary shoots up very well. In English language, there is only one principle that is called split and spell, or break and spell. You have to break the word. Congenial, configuration. Your vocabulary will improve by 1000 words. What is meant by conscience? A person's sense of right or wrong. In Telugu we call it as Atma Sakshi. In Sanskrit it is called Atma Sakshi. In Hindi it is called Atma Sakshi. In Oriya it is called Atma Sakshi. In Punjabi it is called Atma Sakshi. Why in all languages it is called Atma Sakshi? Because in Sanskrit it is called as Atma Sakshi. And 90% of all these languages, the basic words they all come from Sanskrit. So in all languages Atma Sakshi is there. Atma Sakshi is your police. Okay. Question 16.7. The flow in a municipal water supply is usually okay. It is written wrongly. The correct answer is turbulent. Flow in a municipal water supply pipeline is always 100% turbulent. Next, 16.8. The critical velocity in a CI pipe of diameter 1 meter with a liquid of kinematic viscosity so much is equal to 0.002 meter per second. How you have got the answer? What is Reynolds number? Re is equal to Vd by nu. What is this V? When Re is equal to 2000, the corresponding V is known as critical velocity. So what is critical velocity? Critical velocity is the velocity till which the flow is laminar. If the velocity is more than critical velocity, Reynolds number increases. So the laminar flow is disturbed. So critical velocity, up to critical velocity only, the flow is laminar. Once the velocity is more than the critical velocity, the laminar flow is disturbed. So when somebody asks about critical velocity, you have to equate it to 2000. So Re is equal to Vd by nu is equal to 2000. So 2000 into nu. Nu is 1 into 10 to the power of minus 6 meter square per second. He has given it as like this directly, but he may give it as a centi-stoke. Stoke, centi means 0.01 stoke. Centi means 0.01. 1 by 100. Stoke means it is a CGS unit. That is the only parameter it is given in CGS unit. Stoke means centimeter square per second. It is called stoke. So he may give it in centimeter square per second. So you have to convert it. For water, this is this much. You need not remember these values. That is the advantage of gate examination. You need not remember anything. Just observe units and conversion of units you should be good. Centimeter square to meter square, acre to meter square, kg force to Newton. 1 kg force is equal to 9.81 Newton. 1 Pascal is equal to 1 Newton per meter square. These are all very fundamental things. So what is the critical velocity? 0.002 meter per second. Am I clear? Now, let us just, answer is not important. Answer is not important. What you are learning out of the analysis is important. What is the velocity maintained in pipelines? 1 meter per second. What is the velocity here? Critical velocity. That means only when the velocity is 0.002 meter per second or less than that, the flow is laminar. But is there any possibility for such a low velocity? Why? Because in any pipe we maintain a velocity of about 1 meter per second. And here it is 0.002. That means there is absolutely zero chance for the flow in any municipal water line to be laminar. This is very close to municipal water line only. This is actually 1 meter diameter means Kakinada. This is viscosity of water does not change. And velocity is 1 meter per second. Here it is 0.002. Critical velocity. Next question. Equivalent pipes have the same dash and dash. Head loss and discharge. So two pipes are there, which are of different size, different diameter, different length, different material also. But still we call them as equivalent if the head loss is same for the same discharge. Diameter may be different, length may be different, material also may be different. Still we call them as equals if HF is same for the same discharge. That means head loss and discharge are same. The same thing is told in this question number 16.10. A 20 centimeter dia cast iron pipe has a length of 1000 meter. The length of its equivalent pipe of dia 40 centimeter is equal to dash. Question is simple. There is a 1 kilometer pipe, 1 kilometer long pipe. First use common sense only. Think and then try to do something. That only will help you. If you directly use calculator and start doing, you are doing it mechanically. That is vulgarity. You can never learn. Still 90% of you are doing like this. Use calculator only when you have used your mind. For increasing the efficiency of mind, only you have to use calculator. Directly you are using the calculator means you are not on the right track. You are a very stubborn candidate. Stubborn means? Mondi. You are almost like Setaya. నేను ఎన్నో నాకు అన్నీ తెలుసు ఇది నాకు అక్కర్లేదు. So HF is equal to HF1 is equal to HF2. So what is HF? 8FLQ square by pi square g d to the power of 5. 8 into F into L1 into Q square divided by pi square g d1 power 5 is it of L2 Q square by pi square g d to the power 5. For the same discharge, that is why I have put Q. L1 is different. Here it is L1, here it is L2. Here it is D1, here it is D2. All these things they get cancelled. You will get L1 by D1 power 5 is equal to L2 by D2 power 5. So what is L2? Equivalent length you have to find. Its diameter is D2. So L2 is equal to L1 into D2 by D1 to the power of 5 is equal to L1 is 1000 meter. It is given here. 40 by 20 to the power of 5. You have to understand here that 8FL q square by pi square g d to the power of 5 means diameter is in the denominator and it is very, very critical. It is not d, it is d to the power of 5. So if 20 centimeter pipe has some amount of head loss, what happens if the diameter is more? Head loss decreases rapidly. Head loss because it is 1 by d to the power of 5. So 32 times the head loss decreases. That means for the same head loss, length can be increased by 32 times. Then the head loss will be same. So that is the meaning of this term. So what is the answer? 32 kilometer. So if the diameter is doubled, for an equivalent pipe, length can be increased 32 times for the same head loss. Because HF is proportional to 1 by d to the power of 5. 2 to the power of 5 is 32. That is why you will get this. Is it clear? How many of you have done it? Good. Next. You write there. Okay. 1611. How many of you have got A by 3? None. What is meant by hydraulic radius? Area of flow divided by wetted perimeter. Peri is the word which has come from the Sanskrit word pari. What is environment in Sanskrit? Pariyavaranam. Pari plus avaranam. Pari means surrounding. From the Sanskrit word pari, in English peri word has come. Perimeter. Wetted means the portion of the perimeter which is wetted by the liquid. In this case it is water. A is not area. If somebody writes this as area, you are 100% wrong. It is area of the flow. For example, if a pipe, there is a circular pipe of circular cross section. It is running half full. What is A? It is pi d square by 4 divided by 2. That is pi d square by 8. It is not pi d square by 4. Pi d square by 4 is the cross-sectional area of the pipe. Here A is not cross-sectional area of the pipe. It is cross-sectional area of the flow. There is a difference between these two. So this is that. Hydraulic radius is A by P, that is area of flow divided by wetted perimeter. So what is area of the flow? What is area of the flow? This is area of the flow. This is A. This is A. Side is A. So area of the flow is A into A square divided by wetted perimeter is A plus A plus A, 3A. 90% of the students, they do mistake here. Reason is, when they take the wetted perimeter, they exactly make a cross section like this and they close the top also with water. Then that makes the wetted perimeter is 4A. But all of you note an important point. A sewer which conveys wastewater also is a pipe. But the flow in sewer is not pipe flow. It is hydraulically, technically it is open channel flow. So what is open channel flow and what is pipe flow? If the flow is under pressure, And if the pipe is running full, that only is pipe flow. If the pipe is not running full, if the free surface is exposed to atmosphere, it is called open channel flow. So in this particular case, even if you take a closed cross section, you have taken, let us say, closed. But if the top surface of water is touching the top portion of that cross section, it is not pipe flow. There must be at least 1 mm gap. That means it is atmospheric. So that way you have to take, you should not consider the topper, you should take the wetted perimeter as 3A only. Hope everybody is clear? Clear? That is what you have to understand. That the moment it is 100% full, it is pipe flow. It is not open channel flow. But in the question it is given as open channel. It is a canal. So canal means the top free surface should not touch the bottom portion of the top portion, even if it is closed. So this is, so such type of mistakes when you do and correct yourself, and only when you learn these mistakes, you will not do such type of mistakes tomorrow in the examination. So all those mistakes you should do in the classroom itself, so that tomorrow in the gate examination you will not do all these mistakes. Do as many mistakes as you can in the class. Is it clear now? Moody's diagram is drawn by, this is already repeated. How come? Okay. The answer is F versus RE, or roughness factor versus RE. And you should also know that Reynolds number is not, it is logarithmic Reynolds number. 13 question. Hydraulic radius of a pipe of dia D running half full is equal to how much? Okay. For a circular pipe, what is the area of the flow? Running half full. Pi d square by 4 when it runs full. Half full means pi d square by 8 divided by wetted perimeter when it runs full is pi into d. When it runs half full, it is pi into d by 2. It is the perimeter of the pipeline which is in contact with the water. Because the portion of the pipe which is in contact with water only offers resistance to flow. The other portion of water will not offer any resistance. If head loss in a turbulent flow is expressed as HF is equal to K Q to the power of M D to the power of N, then the values of M and R, it is clear, open, and that is 8FLQ square by pi square G D to the power of 5. He said it is Q to the power of something, D to the power of something, N. So the answer is 2 and minus 5, because he has given it as Q to the power of M, D to the power of N. Suppose he gives it as Q to the power of M divided by D to the power of N. Then the answer would be 2 and plus 5. That small changes will be there in the examination, nothing more than that. Question is same. You will try to twist, bend it, break it, heat it, boil it, evaporate it. You will try to do everything, but gold does not change. Truth also is like that. Your answer also will not change. You bend it, you twist it, you apply torsion, you apply compression force, you apply any other force. The last question, if head loss in a laminar flow is expressed as HF is equal to K into K N, then the values of M and R, HF is equal to 128 mu Q L by pi W D to the power of 4. So the answer is Q q by d to the power of 4. So the answer is 1 and minus 4. So what I want to say is, let me tell a few tips to you. Some questions, some formulae are very important to you. These formulae, on the rear side of a drawing sheet, you write with a sketch pen, with your own handwriting, and see that it is there in your room. Instead of having the photograph of Ileana on the left side and Mahesh Babu on the right side, if you have some of the beautiful formulae and books like this on your left side and right side, then definitely that will have a great impression on the heart, on your heart, which is on your left side. So these points, you should continuously see them. It should appear. You will not see them, but whatever you are doing, you are talking to your friend, and wherever your head is moving, you are seeing knowledge, which is useful to you, which will direct you. After some time, what happens? After 10 days or 15 days, you will be bored with it, isn't it? Because once it is completely yours, once that statement starts dancing on your tongue, you will lose interest in that. That is over. You should leave it. Write a new point, a new English word, a new English sentence, or anything beautiful that you should make right on the rear side of a drawing sheet and see that it is pasted in your study room or reading room. So if you can bring a small change like this in your style of studying things, and if you start taking life seriously from now onwards, definitely these things will help you a lot. And we have come to the last 4 classes of this online course. With this, the syllabus will be over, and once the syllabus is over, I will try to cover the such type of short answer questions completely related to the entire subject of environmental engineering. I will be covering once again. I will be in a position to revise the entire course once again for your benefit. But all these things are of a great help to you only when you participate in the class, and you will not get anything, especially some of the students, by cracking a satire on your teacher or saying like this. And my humble request to all the faculty members of the participating colleges is that unless the faculty member is very serious, if I were the faculty members, I would not even sit and listen. I will stand and listen. Because in your class, you are the teacher, you are the supreme. I am not the teacher, you are the teacher. So as a teacher, you stand and continuously watch the students and be serious. That definitely improves the classroom atmosphere. And after almost 3 or 4 years in my career as a professor, I have observed that 3 students have come to my class without calculator. But if this is the case here, this must be the case in every college. But unless we send students out, and unless you are very serious, if you are not serious, this habit will be spread into other students also. And easily a good student is spoiled. So that is the only reason. See that the good student remains good. Then every college has a glorious future. As a teacher, you need not do anything. See that the good student is good. You encourage the students who come with calculator, and don't encourage students who, if they do not come with calculator, ask them to go out. Give attendance, no problem. Do it. But let him not spoil this good student. Here the strength is less. It is only 55. There are several engineering colleges which are using this MOOC class. The strength is about 100, 120. It's a mass. So a lot of disturbance could be there. Unless the faculty member is very serious and committed, this MOOC program cannot be a success.